Can you hear me now? I want to believe you can hear me now. Okay, so as projected, you can go ahead and just go ahead and fill out the attendance. Okay, great. Please let's begin to fill out the attendance if you haven't already. The link is up as well as the QR code. Okay, so to start with today, we're doing a little review on how far we have been able to follow. Okay, I would have done a QR where we can. Okay, you know what? Let me just quickly do that. So I'll set up just something where we can talk about what we'd like us to review because we'll be ending the Python stream um, this session really, or by the next session. Okay, so while we wait for those wait to 10:05, and we'll start off with the hands-on immediately. So while we wait, please let's send in our attendance. Let's call our friends to join. And I'm sure I know a number of people that are joining us online that are still on their way to the call. So we're expecting you to. All right. Thank you. Thank you for saying I look fresh this morning. Thank you. All right. So while we wait, you can just drop on the chat what you've been able to learn in the past few weeks, or if you have a particular area where you like us to review. So just drop that in the chat so that we can just take it up. Thank you. Jesus. Opa Igbo. Thank you. Thank you. Okay. Yeah, so we're getting started soon. I think a good number of people have joined us. All right. All right. So good morning, everyone. So we're getting started immediately. So like I said, if you have any areas where you'd like us to review before we get started today, or even after this session, please just share in the chat so that we can pick that up. Okay. All right. So last week or previous sessions, we've covered quite a lot on data structures. But today, we'll be moving to where a good number of us have been. A good number of us have been, talking about for loops. Good morning, good morning, good morning. Okay. So today we'll talk about branching, looping, functions, and packages, right? So we're going to take what we've learned over the last, I don't know, it's been a number of sessions, right? The last 5 sessions, and then we're going to see how we can combine that to, solve problems really now, because, previously we've been taking variables, we've been doing some arithmetic, we've been doing what else? But now we're going to look at branching, looping, functions, and packages. So what we're doing is using control statements to make decisions, because really problem solving is about making decisions. If this is this, take some certain action. If you see I'm going to be late for where I'm going, send a reminder. If I'm supposed to do something, send a reminder. So really it's about, wow, what's with the voice speed today? Can you hear me? People online, how is the sound? I hope it's better. Okay. So I'm waiting on our response to see. Okay, it's good. All right, great. So conditional statements, we're getting started right away. Okay, so conditional statements. So most of the time when we are programming, we need to perform an action, right? And it's only in, okay, great. It's only in certain cases where we will not need to perform an action, but in every instance, we want to perform an action. So we use the if, elif, and else statements to control, to take action, to take our input and use that to, take a certain course of action, to take some steps, to carry out instructions. And they could be various, they could be conditional, they could depend on certain variables. For example, if somebody types in, we ask for your name, but you typed in an integer. I mean, I don't think a name should be an integer, right? So the program should be able to say, hey, this is not a name, please type something else. That should be a name. So those kind of things and other examples we'll look at today of how we can use if, else, and else for control in cases. All right. So if else statement in Python is really simple. This is a flow chart of what it looks like. And there's a test expression really. And if it's false, there, yes? All right, really sorry about that. Okay, let me just. All right. So we said the body of the if else statement is there is a test expression. If it's evaluated as true, the code in the body of the if statement is run. And you can see the other arrow. If the test expression is false, that is, if it's not true, if it doesn't evaluate to true, if it is otherwise, there is the code in the body of the else statement. And that's what will be run. So the idea is our program can take 2 different branches. If it's not, if we'll see examples, right? That'll make it easier for us to understand. But the idea and the whole concept is if and else, they branch our code. So the code can take 2 different actions based on 1 or more variables. Okay, so what's the format? Basically, there's an if expression and there's a statement, right? And there's an else expression and there's a statement. So the if statement checks whether the expression evaluates to true. And if so, statement 1 is executed. Otherwise, statement 2 is going to be executed. And note, Python is an indented language. That means the space between, maybe let's call it the margin, or between when you start your code and when you type it, It really matters and it follows that pattern, especially for your conditional statement and other things. Because when you type this statement one now, if statement one is going to go to another line, statement two, the next statement that must be run under this if expression must come right under this statement one, as we'll see. So we'll see an example. So let's use comparison operators. Okay, so we learned about comparison operators, right? All right, so what do we want to do? We have two integers, x and y. Let x be 10 and let y be 22. So initialize, we'll let assign integer 10 to variable x and assign integer 22 to variable y. Okay, so now if x is less than y, you can put that in your bracket if you like. So if x is less than y, and then there has to be a colon behind the if statement. It's very important. At the end of your if statement, there has to be a colon. So put a colon, and if you press enter right after that colon to move to the next line, Jupyter will automatically indent the code for you, right? You will see that it will be automatically indented. So, however, if you're on your phone or somewhere else, you can just, the convention is 4 spaces, right? Okay, so if x is less than y, print x is less than y. Then we reset the indent. So you can use Shift Tab to move your indent to the previous block of code. So else takes its own indent. You see it's right under if, it's not under print, it's under if, right? So else, put your colon, then print x is greater than y. What's going on here? We have two variables we are comparing, x and y. We've told that what this code is saying is, if x is less than y, execute this print function. X is less than y. Else means what? If x is not less than, what's the opposite? Else is simply if this expression evaluates to false. That is, if x is, now here's the funny part, or let's say here is where it must be well defined what we are trying to do, right? And what is it that we're trying to do? We're saying if x is less than y. Quick question: what are the various forms of this expression that can evaluate to false? Like the opposite, like if x is less than y is true. False means what? X is greater than y, or x is equal to y. So there are two things that could be going on there. All right, so let's run this, and we must get what should we get when we run this? We must get, what should we get when we run this? We should get x is less than y. How many of us got that? Great. So if we add something else to this, right? Just next, enter after the print block of print. We can say print x is less than y. We can say x. Let's have another print. Or let's change this. Print x is a number greater than and just say y. So you see, so when you print, you say x is a number greater than 22. So x is a number greater than 22, right? Let's make it a bit more fun. We can say x equals to, put the input function, so we can affect this code as it runs. And what will the input function? Right in between the parentheses, type in enter an integer. Now it has to be an integer for it to work, because we understand that whatever we type into the input function becomes a what? String. So to make this work properly, or let's run it without the and let's see the kind of errors we get. Enter an integer and enter 4. Who wants to give us an idea of the kind of error we're going to get, or maybe we'll not get an error? Type error. Why? We cannot compare a string and an integer, so we need to make this an integer. So we bring here int, right? Let's run that again now. So enter an integer, any integer. Let's enter 67. X is greater than y. Now, it's just saying x is greater than y because we are currently, okay, x less than y. Okay, so if x is less than y, because x is a number, it should be less than y. Okay, great. So else x is greater than y. Okay, so we're trying to see how we can use different values here. So let's change our print functions. So if x is less than y, let's print, we want x itself to be printed, right? So let's come here and type x, comma, or we can use the string format method that we learned, right? Let's use string format, x is a number less than y. It's that simple. And if x is greater than y or equal to, just say x is greater than or equal to y. Okay. Oh, okay, let me make that bigger. Oh, this is fine. Okay. So I trust that people online are following as well. So let's try this out. So enter an integer, 67 again. 67 is greater than or equal to 22. Now you'd be like, of course, 67 is not equal to 22, but the code we only give to one condition, right? So it's either if or else. When we get to Elif, we'll see how we can account for all different conditions. And now Python has switch case. We'll not cover, we might not get to that here, but just know that with switch case, you can make instances of different cases as much as you want, and then give some action. So what if we actually type 22? If x was 22, 22 is greater than or equal to 22, right? And this is because it's only checking one condition, greater than, less than. That's the only condition, right? So we can't say, so if we want to say what if it's equals, we want that one to be separate. We can use Elif, and we can actually still use another if, but we want another block of code. So that's about that. Let's try writing a string here. What's going to be the error? Type value error, invalid literal for an integer. Okay, so we can try with a bunch of different numbers. It's greater than or equal to 22. So this way we are saying if a condition is true, do this. If the condition is false, do this. Let's look at another example. So this is what we just did now using print format. Exactly the same thing we just did now. Okay, so let x be 10, let y be 22 again. If x is less than y, print. Now x equals to this is less than. Do we see? It's exactly what we did above using print format method. Okay. So example 3, write a Python code, okay, if else statement that checks whether a given variable is an even or an odd number. Now we are applying everything we've been learning. Now we know that it's a simple condition. An even number. So we want to write a code that will check if the number inputted is an even number or an odd number. So we want this thing to be able to take. Okay, so you can go over the video for any area where I was fast, but I think we are moving on a bit fast today. So I'll slow down. Okay, so we said if else statement to check whether a variable is an even or an odd number. So how do you think we can do that? Yeah, I know we can see it, but just intuitively, an even number is a number that divided by 2, the remainder will be. And if we divide the number by 2, an odd number, the remainder should be 1. I mean, you should have the last remainder will be something like 1, right? Not 0. That basically the idea is it should not be 0. Do you see that? The basic idea is it should, I mean, there can be all sorts of remainders, right? But the basic idea is we shall know that when you divide an odd number, the remainder must be something greater than 0. So, and the remainder, right? Not the quotient now. So we want this thing to be able to take various inputs. So enter an integer. Okay? And now we use the modulus. Do you remember the modulus operator? It returns the remainder. So if x modulus 2 is 0, that is the remainder when you divide by 2 is 0. Print what? X is an even number. I want it to actually print that x. So print, so that's x. So I'm not using the print format method here. So print x is an even number, else print, or is there something else x can be if not an odd number? Is either an even number or an odd number? So let's run this. So whatever number, let's have 2. Ooh, why we get an error? Beautiful. int, make sure you convert whatever goes in there to an integer. So let's do 45. It's an odd number. 2 is an even number. Odd or even? It's odd. Even. So once you can represent your problem with a set of rules or conditions, you are able to use if-else statement to manipulate, arrive at a result, take some action, output some action, do something. And as we'll be learning in, when we get to machine learning and we are, maybe you're wrangling your data, you're trying to find something. If this thing is here, and most times I never use if because most times we use maybe pandas directly. But the idea and the concept is if your problem can be represented as a condition, you can always use the if else to check for it, and you can take some action depending on if it's true or false. For example, if someone is detected that the person maybe has showing symptoms of coronavirus, or maybe you imagine there's a system that can detect temperature, right? It can detect temperature without contact, right? So, and maybe it's here, someone just walks through the door. If the temperature is, so a way to do that is you want to detect the temperature, a symptom of high temperature. If the temperature is above this, sound an alarm. It's the same concept. So here it will be if the temperature, if we're coding maybe an embedded system or a machine to do that now, there'll be a sensor that will receive a high value, right? And when you use the high value, it will turn on and hear an alarm. Or we can just print something as well. So that's the whole idea that if a condition is true, if a condition is print something. The same way, what if we wanted to print a welcome message every time someone entered a number or entered when you log into your computer greets you, welcome, and you say your name. So we can also do something like that with if else. Okay, so let's do this guessing game. So we want to know whether our friends can guess ATM passwords accurately. And let's say we've written the code that we're going to see below, and then ask people to just guess, right? So it's a very fun game, or to just check. So let's say it's a password. Let's make it it has to be 5. Let's say it has to be 2 letters, so that 2 numbers. So same password is so let's have a safe password. The number we're looking for is 35, right? Now, the new password input, please guess my password. What this block of code does is what? Requests, please guess my password, and the person is allowed to enter what? An integer, right? And if new password is what? Actually the same as the safe password, print password correct. Else, print what? A criminal. So imagine somebody is trying to access a computer, access something, and so if you want to say, please guess my password. And I mean, maybe we've not seen before that I set that 35, 67. Ooh, I'm not a criminal. And you can go on and on and on like that, right? Another beautiful way is if we generated the safe password randomly. And it's a very fun game. I mean, it's one of the biggest games that you want to just entertain someone or something. You can just pick a random integer, right, between a range, and then the person has to keep guessing. And because it's random, even you do not know what the correct answer will be, right? So you just something to guess. So I think that can be done with, I think it's rand. No, is it random? I'm not sure it should. I don't remember what it is now. Is it random? Maybe random. But yeah. So, but let's leave it as let me just check that. Someone just quickly look that up for us. No, it should be. Yeah, I remember. I remember now because I don't want to import any functions yet. Yeah, so that's fine. Okay, so we'll get to that later. Then we can do that later. Okay, so let's test if A is less than B and if C is greater than A. So now we use the and operator. I mean, it's even clearly there in our test, right? So let A be 10, let B be 13, let C be 16. What's going to be our if condition? If A is greater than B, right? And C is greater than A. So what we want to check is if both conditions are true. That is A less than B? So we are using A greater than B here. So we can use A, let's use directly with the question. So if A is less than B and C is greater than A. So if both are true, that's what we're looking for. So we're using and. That means both must be true for and to evaluate to true. So you see, Boolean is coming to play in an if else. So it's the same way we combine different data structures, data type. In a real world problem that we're solving, you are combining your data types, your data structures, list, you can combine this with your dictionary, so many things just to solve a problem. Okay, so print both conditions are true, right? Else print none of the conditions is true. Now, if we have, I'm going to ask a question. Yes. Is it possible for us to have, using the AND operator, is it possible for us to have another possibility with this? That is it possible for us to have one of the conditions is true? Is that possible? No. Is that possible with AND operator? So the question is, with the AND operator, is it possible for us to have, if we create an option here and we say one of the conditions is true, using just this expression, would that be possible with the AND operator? No, it's not possible. Would it be possible with the AND operator? No. So remember that the AND operator will only evaluate to true if both conditions are true. So that will not be, of course, there's a way you can write it, but what I'm trying to ask is that AND will only evaluate to true if both conditions are true. So running this, we can already say if A is 10 and B is 13 and C is 16, both conditions are true. That is, A is less than B and C is greater than A. If we change them up again, we can say A is int input enter A, right? Come here again, int input enter B, and lastly int input enter. Now I know some of us might be asking, we can actually use any, we could just initialize directly, but the reason I'm using this is so that we can try different variable values out and just explore different options. Okay. All right. So enter A, enter B, enter C. Both conditions are true. A is less than B and C is greater than A. Let's run it again with 56, 11, 2. None of the conditions, maybe it should be true. Is it true? None of it is true. So none of the condition is true, and we have what we have here. So is actually, so what's the first condition? Is A less than B? No. Second condition, C is greater than A. Is C greater than A? No. So this, and now, what if we did, let's see B. So C is supposed to be greater than A, right? Let's make C not to be, what we type not to be greater than A. So A is, let A be 6. Let B be what? Let's say 4. No, I won't want to correct. So condition is A should be less than B. So let B be 10. And let's C now be less than A. So 4. It says none of the condition is true, but there's one, is there not one condition that is true? Why? A is less than B. Well, because we've used the AND operator, and only if both are true will it evaluate to true. So it's evaluating to false, and that's the only, so that's why, and we've said here that none of the condition is true. So that means whenever you are choosing your operators, you are choosing the logical operators you will use, you are choosing the expressions you will use, you must have your clear answer in mind, especially when it's a logical expression, because you might not get an error, but you might not get a type error that will stop your code, or attribute error that will stop your code and tell you there's an error. You can get a logical error where your code will run and you get an answer, but the answer will not be what you are actually expecting or supposed to get. Or you get an answer. For example, this says none of the conditions is true, but we know that one of the conditions is true, right? Right? Yes. What's the condition that is true? A is less than B. All right, so let's move on. So, beautiful. So you want to transfer money from your account, and you don't need funds are enough. So let's say amount in bank, plenty money, and amount you want to transfer is input. Okay, so let's run this. So if amount in bank is greater than amount you want to transfer, it should bring transfer successful, right? You can send that amount. But if it's less, transfer failed. Imagine if the person, maybe the person that wrote the codes that run our ATM machines, instead of using greater than here, use less than. Now, of course, also we know that there's no money in the account, so we shouldn't even go. But imagine if the bank, the money could just be forced to prove from the bank results. Can you imagine that it's only 500 naira in the account, right? But I thought, have you ever had an error like that on your bank account? I doubt that is possible, right? So how much would you like to send? 134. But there's plenty money now. Oh, we've switched the logical operator, right? So amount in bank must be greater than transfer amount waiting successful. Let's reduce this so that we can play around with this a bit. So 5,000. How much would you like to send? Someone send 2,000, 2K ASAP. And what do we have? Transfer successful. Why? Amount in bank is greater than transfer amount. So the code under the if, which is when the true is printed, else is only when, let's try that. Let's say we want to transfer 50,000. Transfer failed, not enough funds, right? So any errors, any issues on if else so far? None. Great. So we'll add one more called Elif. What does Elif do? So we have multiple conditions we want to check for. Right? Now, if else we only check one condition, but we have multiple conditions we actually want to check for. So what can we do? We can use the Elif keyword to check for as many individual conditions as possible. We have X, we have Y. Now, if X is equal to Y, print. Now let's use, I don't want us to use things that relate to this. So X is what? Equal to Y. Yeah, so I'm seeing people raising their hands in the chat on Zoom. So just ask your question in the chat if you have questions. Now, if it means else. If so, just as it implies, Elif is just else if. So else if X is greater than Y, right? Print what? X is greater than Y. Now, if X is equal to 100, or if else is 100, print X is actually 100. Now, else. We can now close everything with else. If none of the conditions, though we've stated 3 conditions here. How many conditions have we stated here? 3. If X is Y, if X is greater than Y, if X is equal to 100. Remember, there's a difference between equal to and double equal to, right? Single equal to is assignment, the double equal to is a comparison operator. So when we run this now, it says none of the above conditions are true. That means X is not equal to Y, X is not greater than Y, and X is not 100. So we want this to be more flexible. So input, enter X, input, enter what? Y. So you can type this out and see how it goes. You can really change the operators, play around, get your errors, and let's debug them. So enter X, let's call X 4. Enter Y, let's call Y 89. Says none of the conditions are true. And true, none of the conditions are true. So what if X was 100? Remember we wrote the code something like there's a condition that says if X is 100, right? That's why be 200. X is actually 100. So we can go on and on and on like that and really check for anything. As long as what you want to check for can be represented, you can express it in a Python syntax, in a programming syntax. You can check for that condition. I'll give an example. Now, this was actually, even in Python, you can do the same thing. I wanted to check for different columns if something was missing, and if it was missing that column, check another column. If it's missing there, keep checking until we find it. And it was just a very long if, Elif. And normally, even if you say it logically, you may start getting confusing for you. But as long as you can represent your condition in a Python syntax, you can use Python to solve that problem. Is that clear? Does that make sense? Okay, great. So, question. Yeah. Yeah, so we mentioned that Python is indented, and that means if I have this, right after my if, I put my colon, if you press enter, Jupyter will take you directly, so it's asking about an indentation error. So if you press an enter directly after the colon, Jupyter will indent automatically for you, and your cursor will start here. See? Enter, keep starting there. And if I press shift tab, it will take me back to the last indented block. So as long as I am under I'm still checking the condition. I'm still following the true path. That is, if the condition evaluates to true, everything must be under the same indent. Else, and in the same block, you can't have different indents. Otherwise, you won't get an error. So if I said, see this print here, if I did this, I will get an indentation error. This should be an indented block. Python expects an indented block here. So tab will solve that for us. Okay, so indentation super important. Okay, so which other one? So we're looking at else if. So now let's go back to the first example we did where I mentioned, is this it? Okay, it was this one. Where we said this is greater than or equal to, right? Now we can use else, Elif. So if x is less than y, print x is a number less than y. New block. You see, this is a new block now. It's not under the if because we are creating a new condition, right? It's not following the previous condition. We are creating a new condition. So I type L if I write my condition, and that is x what equals to y. Print x is actually equal to y. So then I can now use the else now, because if it's not less than, it's not equal to, the only thing it can be is greater than. So I cannot use else if I don't type out greater than. I don't type out that condition. And sometimes there could be, imagine there could be 100 possibilities. There could be 100 conditions, but I'm only interested in 4 of them. I can create the first condition using what? If, right? Second condition using Elif. Third condition using Elif. Fourth condition using Elif. And for all the other 96, there are 100 conditions, right? The other 96 conditions, I want them to evaluate the same thing. All I have to say is else. Do we get that? So else will take anything that is not any other result that is not one of the that is not stated in your conditions will fall under else. For example, if we said we are trying to check if Ado Agbemi and what's her name? Olumide and Olumide came to class today, and we have the list of everybody that came to class today. While everybody is on the list, so imagine all of us say we are 23. That means there are 23 people. There are 23 possibilities of well, not talk in terms of probability now, but just in terms of the conditions. If you wanted to check one by one, so we say if Olumide is in the list of attendance, print this. If Ado Agbemi is in the list of attendance, print this. Else, we don't want to, like we said, we are not bothered about other students at that time. So else, Olumide and Ado Agbemi are not in class, or other students are present, but so every other condition can be neglected and they will evaluate the same thing under else. Okay, so we could use okay, we've not it's not done, but it's the same thing. We can just say, let's give an example. Say we create a list to say students. Let's create a list. Give me names. We've used Adora Bimi. We used Olumide. So I just want to type out what I just explained. One more name, Richard. Okay. One more. Let's use one more. I didn't hear you. Ore. Ore. Okay, great. So I was going to say that before. No, once I see this, my mind just goes to 4. So let's say student 1, that we actually want to check for is Adura Baby. Now, I can say Adura Baby again, right? Or I can just say students. What's the list is students, right? What index is Adura Baby? 0. And that's Adura Baby. And student 2. Now let's use Richard. What index is Richard? Yeah. Now, if student 1 is in students, print 1 is in class, right? Else, if student 2. Now you see how we can make so many different is what is in students. Print is in class, right? Let's take one more. Now, let's say else. Print. Let's say else. Print. That means student 1 is not in class. Student 2 is not in class. We get that? Is that clear? Because what we are saying is check condition 1, check condition 2. None of them are true because only one will be, only one of them will be evaluated. So check condition 1, check condition 2, none of them are true. Print. I want to print everything, but okay, when we get for loops, so I don't want us to go ahead of ourselves. So print student 1. Formats have been easier here, and student 2 are not in class. Quick question. With this list and our what we've stated, is it possible for us this else statement to actually run? Will the else statement run? It will never run. Why? And you notice it doesn't say it's only the first one that runs. Why? It will, like we mentioned, only one of them, we are checking different conditions, only one will be evaluated. So if we want to actually check that, oh, okay, we want to actually check that Richard is also in class. What we can say is if student 1 in class or in the list of students, print what student 1 and what? Is that correct? Yes. Are in class. So what we get is what? Adorabumi and Richard are in class. So we could now, the same way, we want to play around. Now, let's add one more. Look at that. Say Elif, else if student. So if student, let me say not in, right? So that we are showing this one there evaluate. So we want if student 3 is give us just like any condition. If student 3 is students, Olumide all right, so let's change this to an input 2 so that that's not so we can. Are we catching on? Okay, no questions so far. So enter a student name. This will be student 1, right? So let's use a name that is not there in the list. Funminiyi. Okay, another student name. Now let's use. So this is student So let's now use Funminiyi, right? What's printed here is what? Student 1 and student 2 are in class. Where is that? This. Sorry, no. Okay, no, it's not this. It's this that is printed. And why? So we can now check it out. Why is this printed? What student 1? Input the student name. If student 1 student 2. Okay. So let me show that I type name, right? And enter another student name. Oh, all right. Oh, that's nice. So okay, let me run that again. So what we used, what was student 3? Olumide, right? Actually like this. So now but what's being printed is this condition, right? Meaning this condition evaluated to true. This, right? The only way this will be printed is if this evaluates to true. That is student 1 and student 2 are in class. But Funminiyi and Richard Funminiyi is not here. Only Richard was here. So how come? Where is it? Funminiyi and Richard. Now, if we recall, we said that the AND statement will never evaluate to true if both of them are actually there. So I believe this should solve that. No. Okay. Good. So that's an example of a logical error, meaning we got an answer, right? But that's not the answer we expected. So we can debug. So let's try to debug that. You can try it at your end too. So student 1, this student name will enter that. Student 3, student 2, not 8 students. Okay. Right? Is it clear now? Yeah. So I'll explain. So before, the way we wrote the code only checked if one of them was there. It was checking it as, it took it as one single line. So, but now we are saying, no. Check if actually this one is a student. And at the same time, this guy is also there. Only if both of them are there, print this. So since both of them are not there, this will be printed. Now, if student 2 is not there, this will be printed because we said not, right? And the last one, we said now, if student 3 is actually Olumide, print Olumide is in class. So this way we can, this is just to show, I felt because we generated an input, beautiful, yes, that's correct. So this way we are able to really take what this will just show here is that you can think of any condition. Once you can represent it using the operators available in Python, we can write. Okay, let's move on. So we're looking at print formatting. We just went back to the top. Okay, so loops. Welcome to loops. Loops are really beautiful. Loops help us to iterate through attributes like lists, dictionaries, tuples, and the whole goal is you can do a task, you can run a line of code for multiple lines. For example, okay, question, can somebody here add every number between 1 and 1 million and tell us the results? So 1 plus 2 plus 3 plus 4 plus 5 up until 1 million. What's the answer? Nobody, no, is it math Olympiad now? I mean, even if you do it by hand, it's hard. Of course, we can use all these statistical theorems to do that. It's still going to take a while, right? But with Python, we can actually just write a simple for loop for I a range to 1 million, I plus the next one. Does that code make sense to us? Okay, let's look at it. So there are two types of loops in Python. There's a for loop and there's a while loop. The for loop is used to iterate over a sequence of objects like a list, a tuple, a string, or a dictionary. And what's the syntax? For any item in your object, your colon, and then remember there is the indentation. But as always, remember Jupyter will automatically indent for you. But if it's not, just press a tab or use 4 spaces. So the naming of the item is completely up to you. You can use anything. But it's always cool because Python is a high level language that we learned in the first class. That means you can really use anything that makes sense to you. And it's always advisable you make your code as human readable as possible. Right? So don't be, you don't write a code, you are looking for alpha consonants in maybe a list of consonants, and then you call the consonants vowel. I know, of course, the code will run normal, but it doesn't make logic reading sense. So as much as possible, I know we like to play around. It's just really good. Someone just can pick your code and easily understand what you are doing, right? So it's always very nice to just make your code as readable as possible. So what we've been playing with all along, I remember you will recall that we've been using this kind of code. So we have a list of fruits. Fridge, this is a list, right? We have mango, orange, apple, lemon, banana, grape, cherry, avocado, up onto watermelon. Now we want to print each of these items. So all we say is for fruits in fridge, print fruit. What's going to happen? It will print all of them one by one. I can change fruit to Funminiyi. The code doesn't mind, as long as what I'm asking to print is still what? So it's still going to run. I can call this anything, print anything. So what's happening here is it will go through fridge, take the first item, mango. It will do this to run this function on mango. Take the second item, orange. It will run this print function on orange. That's why we have this result. Take this next item, what? Apple. Up onto the last item. So it will continue like that and run through the list or whatever iterable up onto the last element. Does that make sense? Okay. Let's look at this. So we want to print the square of each number in the list. We have 1, 2, 3, 4, 5, 6. So, and we created a list called my list. So for number in my list, remember this can actually be anything, but it doesn't make sense for us to use number, right? It's related to what we are doing. So for number in my list, print what? Number raised to power 2. So what's going to happen? It will run the first one to say 1 raised to power. Let me do this. Let me just put the output. So it will say 1. That's the first item. Raise it to the power of 2. The answer is 1. So the answer we're expecting is 1. If you say the next item in the list is what? 2. Raise to the power of 2 is 4. Next item is 3. Raise to the power of 3 is 4. Then 5 is what? 25. 6 is 36. Oh, 16, yes. And 16 is just 1, 2, 3, 9. 16 is here. Yeah. So you see 1, 4, 9, 16, 25, 36. So it will iterate through that list. It will move through that list in the step, always in step of 1, and to run whatever code. If we said, we could have said, another way to run this is create a variable, call it square, equals to number raised to power 2, right? So what we print here is just what? Square. Beautiful. Okay. Or square is this, right? Let's add more things. Square, this is square. Or we want to find, imagine if we had a list of lists where each list where each list was the length and the breadth of a rectangle. Let's do something like that. So I want to find the area of each of the rectangles. So the first item here, let's say length is 3, breadth is, really, we don't care about the order, we just want our list. Let's say 2 and 6. Let's say 5, 4, and give me numbers now. 7 and look at how hard it is to be random. I'm trying to be random, but I'm just trying to do something. Okay. And the last one, let's just say what now? 20. Okay. So for, let's call this rectangle in my list, right? We want to calculate the area of each of these rectangles, the length. So this is a list of lists, right? This is a nested list. The first item is a list. Second item is a list on its own, although there are 2 elements in each of them, right? Right? So for a rectangle in my list, we define our formula for area and say let area be length times breadth. So what's the length? Let's say the length is the first one. So that is rectangle. What's the index? 0 times rectangle index. What's the index? 1. So square. Let's just square again. So now print what? Area. So print area. So let's make it. Let's try to make it a text. So area of rectangle of length, and we can say, let's make it a bit pretty. Length is what? Rectangle, the item at index 0, right? And breadth is the item at index 1, right? And more intuitive, just area is what? Length times breadth. So we've assigned these already to length, assign this to breadth, and just the area is length times breadth. So area of rectangle of length, comma, length, and breadth of comma, breadth is what? Don't forget this guy, area. So area, okay, cool. So when we print this, we can already know what we're expecting. So what are we expecting? 3 times 5? Okay. And 70. Yeah. 100. I think that's the last one. So 15, 20, 12, 36, 1700. So area of rectangle of length 3 and breadth 5 is 15. Area, you see, it just does that on and on and on like that. So you can actually check. What the code is doing is picks the first item in the list, right? It will run everything under the for loop for that item. Everything. So it's running everything. It sets the length, it sets the breadth, it does the area, and then it prints this. So this is for the first item. This is what? Second item, third item, fourth item, and fifth item. So and on like that, we can continue and keep getting whatever it is. You can set. So try to think of a real life case where this is. Imagine we have what comes to my mind is with physics where maybe we want to calculate, we give us a periodic table, find the combination of an element that will produce this for every element in periodic table. Great. If I was doing that, the first thing I would do is I'll just create a dictionary. The key would be the name of the element and the value will be maybe the valence electrons or whatever as an integer, right? And we can do what we do with them. Or so the idea really is just that once you can iterate through something, so a list, your string, your dictionary, your tuples, you can iterate through them. You can store things and you want to keep, you want to repeat that operation, you want to repeat that task, right? For every time it encounters this item, do this, do this, do this. For every time you want to compute scores, let's say you want to compute your 3 scores now. For every student in the student list, find the ID, dictionary, right? Your key will be your ID, your value will be your name. Keys have to be unique, so keys will be ID, value will be name. And then we now say, so for each student, maybe we use a function compute score. So we won't be writing it one by one for this student to do this, for this student. So just for each student, compute score. And it will run through the list of all the students and compute the score for each one of them. Are we clear on for loops? For loops is not clear, right? For loops is not clear, right? It's not clear. Okay. So where is it not clear? So I'll just go right again. Where? Huh? Yeah, so if we use just okay, so this is okay. So I've removed all the things we use to format our answer to infinity, and here we have that just printing normally. Now, let's say for a rectangle in this, don't worry about all this. Just print. Okay, that's right. I didn't want to print it. Let me just print rectangle. So what it has done is what it's been doing all the while. We told the code go through the list for every item in that list. Print out that item. When you encounter an item, print out the item. It will go through this entire list and it will do this, it will do everything under the block of the for loop for every item. So it will take the first item, list 3,5, it will print it. Take the second item, list 2,6, it will print it. Take the third item, print it. Fourth item, print it. Fifth item, print it. Seventh, on and on. Like if we have a million items, it will print it. Of course, we might run out of memory and your computer may crash, but it will attempt to print everything. And if you're using a supercomputer, lucky you, it will print everything. Okay, so if you need to go by it again, just you can watch the video to do that. So it's the same way when we did for the rectangle thing. It will run everything we've put under the block of for loop for every item in the list. So the idea of a for loop is for every item in the iterable, the item here is rectangle. Rectangle can be anything, like we said earlier. I can change this rectangle to onion. As long as I change everywhere I put rectangle to onion, the code will run fine. So for every item in the list right here, it will take that item, do the length as the first item in that list of lists, set the breadth as the item at index 1, set the area to now be the length times the breadth. Then it will print the area. So that means the result we'll get is this. So takes the first list of lists, length is 3, right? The breadth is 5, 3 times 5, 15, and on like that. If this list continue to 1,000, it will just keep running unless we tell it to stop, and we can tell it to stop. Okay. So print the square of each number from 0 to 9 using the range function. You will recall we talked about the range function earlier, and the range function is really beautiful because once we say 10, we need to start from 0, end at index 10, which will be 9, right? So 0 to 9, there will be 10 elements. So for I in range 10, remember, it doesn't have to be I, it can be anything. Print I, print a colon, then print I squared. Right? So it will start from 0. 0 squared is what? 0. 1 squared is 1. 2 squared is 4. On and on and on and on like that. So that's basically it. Once you define your for loop, how you want to iterate for this item in this whatever range in this list, what do you want to do? We want to print I, we want to print colon, and we want to print the square of value I. Is that clear? Okay, let's try that with a string. Country is Nigeria. For every character in country, print the character. So if you print all the letters in Nigeria, you can try it out. Let's try it out with give me another country. How the countries? We just finished Tokyo Olympics. So for every character in country, print it out TOKY. Oh. For every this could be my name. So many eyes. You get what? It will print out each character. Okay. So we'll take this is a tuple, right? Teacher's names. Remember our string formatting method. So for teacher in teacher's name, right? For every item here, it will take the name, run this format method on it. So this is only print again. This is Shadi. What's the next item? Abdullahi. This is Abdullahi. This is Jamal. So that's it. Whatever you define under your for loop will be run for every item in the iterable. Your iterable is your list, your dictionary, your tuple, your string, your series, your set, your array. What does an iterable? Not an integer. It's not an iterable unless you pass that integer into a range function that now creates an iterable with that number of elements. All right, so let's move on. For loop with dictionary. Now this one is this is pretty. So life expectancy. Remember our life expectancy dictionary. If you want to look through this now, dictionary is key and value pairs, right? So for country in life expectancy dot keys, the keys method returns what? All the keys in the dictionary. So life expectancy dot keys print country for each country. What is it going to print? All the keys for us. Okay, we didn't run this. Right? She's going to print out all this for us. Wow, we've not had our break. We should take a break soon. Okay. So for year in life expectancy dot values, print year. Right? So now it will ignore the keys, right? But values returns only the values, right? So it will ignore the keys and print out values this here. So that's 60, 69, just as here. Right? So now for country in life expectancy dot keys, print country. Now print life expectancy. Remember when you pass the key of a dictionary as an index to that dictionary, what does the dictionary return? The dictionary returns the value at that key. Remember we said that in the dictionary, your keys are like your index. We mentioned this in the last class that the keys of the dictionary are like the index of the dictionary, like your 01 in your list or in your tuple or whatever iterable. So if you pass that index or that key into your square bracket for the dictionary, that value that represents. So let's take a look at this. If I pass Nigeria as a key in life expectancy, I will get 60. If I pass Kenya as a key in life expectancy, I will get 69. What are we saying? This is just it. So if I have life, let's see, square bracket, Nigeria, get 60. If I change this to Uganda, get 68. Somalia, get 54. So just the same way, so that's what's happening here. Right? So for each key, right? For this can be key. It really doesn't matter. So it makes more sense to us. So for key in life expectancy dot keys, print key. So print the key. That is print the country. And for that same key, use it as an index, right? Into life expectancy, and then print that value, because this will return the value. This is what we are doing, but we're not doing it in a for loop. We are saying print the key, is print the country, print the value of that key, then move to a new line. If you run this, we'll get this definitely. So I'm going to give us, let's do a little classwork just after this here now. So let's create a, oh, I thought I copied it. Okay. Let's call this class record. And we have a test. Funmi had 60. Toby had 9. Adura Baby had 68. Olumide had 68 too. Let's say Leke had 6 as well. We can say you can drop your questions or comments in chat. Pukumi had 5. Don't mind me. And we can say who else? Give me a name. Let me say name here. I'll use my name for this topic. Niyi had 64. Okay, one more name. Ore had 54. So this classwork. Now, let's print what we are. What's the assignment or what's the classwork that we are going to do? So the classwork is, so let me first, so this is the dictionary. Let me make it a bit so everyone can see clearly. All right, so this is your dictionary. So this is your dictionary. And what we are going to do with the dictionary is, so print the score for each student by iterating through the dictionary keys. Hold on. Results, printed results should be in the format below. So let's check this out. Let's try this. And the result should be in the format name and score. Hey. Okay. So let's have it in this format. Oh, it's marked down. So let's just say name and score. Name. So name is the student's name, right? Let me just make this name and score. Score is your score value. So when you're printing out, so for each score, so this is it. So for each, so we are printing out the score for each student by iterating through the dictionary keys.
So the printed result should be in the format name hard score value. So for example, what we should see is Fumi hard score 60, Toby hard score 9, right? I do agree. Let me drop an example. Example is Fumi hard score 9. Is it clear? All right, great. So I'll give us about 10 minutes to do this. That's the dictionary above there. So we'll have till 11:30 to do that. Okay. I think we can do this in lesser time. We've gone about examples like this. So if you have any issues, reach out. So I'll just, while we work, I'll move around a bit and just see. Okay. No, it's So we are using the for loop. So you're supposed to use the for loop for this exercise. So just iterate the for loop. I didn't state it in the, I think How did we do? People online especially. Okay. Okay. All right. So people online, any seat ID. Okay, so people on online, please just confirm that you can hear me. Just need a confirmation that you can hear me loud and clear. Okay, great. So, all right, great. Okay, so let's run a correction. So the goal was to print something that looked like Fumi had score 9. I want to print it for every record that we have here. Okay, so this is our dictionary. So how do we go about that? First thing is really simple, just for, right? Call it record, or let's call it record in class underscore record dot keys. Now, what are we doing here? So what are we doing here? What we are doing here is, if record in class record dot keys is class record dot keys, the calling dot keys method on class record returns a list of dictionary keys. So what we are doing actually is we are iterating through the keys. So let's confirm that. I want to break this down as much as I can. Class record dot keys. Right, so dictionary keys, we can see that. So all the keys, okay, all the keys are listed. So that's that. We know that's correct. So next thing I need to do is, remember the format we are printing is Fumi at score 9. So I need the key and I need the value. So I can just say key is record and value is class. So I need to index. So value is class underscore record and the index. Okay, so class is, where are we? Value is, so we talked about the key is what we are iterating through, right? Is it clear so far? Key is what we are iterating through. The value is class record index by the key, because the key is record. Record is returning the keys that we are iterating to dictionary keys. Does this make sense up to here? Does it make sense? Do we all, please stop me? I'm using people here physically. Someone said no. So what's the issue? So what's not clear? Please, we need to know what's not clear exactly. All right. So for record in class record.keys, I have shown below here. Okay, so let's go over the last class, what we talked in the last class, the dictionary methods. We said class record.keys will return a list of dictionary keys. So this is a list, and this is what we are iterating through here, because this is the same thing as this. So to make it comfortable for us, every record from here, store it in a variable called key. That means every key because this is dictionary key, store it in a variable called key, and the value for this key is going to be what? The dictionary itself indexed by the key. So we know that whenever you index a dictionary by the key, it will return the value. But whenever you index a dictionary by the key, we will get the value. So if I say class underscore record, right? I open my square bracket and I say Fumi. It will return the value for Fumi, which is 60. So that's what we are doing here. Because key is now what? Key is like Fumi, and value is going to be class record key. Is it clear now? Thank you. Next thing is we want to print. And all we are printing is to be in the format, the name hard-score value. Fumi hard-score 9 is our example. So let's do that. So that means first thing we're printing is the key, comma, right? Comma, then hard score. So we know what we have the string hard score preset. What's next? And value. So if I run this now, we are going to have every item manipulated true, presenting that simple. Now, I know some people you might have, but this is the basic principle. Another way you could actually do this is because if you iterate through a dictionary by default, you will just be iterating through the keys. So even if you don't do dictionary.keys, it still give me the same thing. Right? So but let's take it back so that everybody is on the same page. All right. So is this clear? All right. So how many of us through this correction you are able to see your mistakes? Okay, so can we try that again? Okay, so let's try it again with a different let's see now. Rather than Fumi, let's have let's call this 200. Okay. All right. So we have a new dictionary. Now the keys are integers and the values are different food items. This is let's use now food. This is now food record. Right? Now let's reverse the question. Print so the cost is the key, right? Let me just define that. So the cost is the integer key value, right? That's the cost. So what we're going to do now is let us try. So you are going to try now, even if you are online, offline. So you are going to try to output for every food item, output this. So we are iterating using a for loop. Our example, this is what we want to see. We want to see I bought food for cost naira. Food is the dictionary. No, food is dictionary value while cost. So I kind of reversed it. I just reversed it. So let's iterate through and let's output and output our result to be I bought food for cost naira, and food is your dictionary value while cost is your key, right? Integer. So can we all try this? Please. Why should stop? You don't want to try it? Please, let's all try this. Let's all try this, please. Let's try this. This is how we know that, okay, yeah, I get the concept now. Okay. So we have the same, we have 7 minutes left. Any issues? So I reversed the we are used to not in an integer. So I just that I can use different methods. Like I like what I do. We use the item method. All right, so we have people. All right, so correction now. Let me see on the chat. Yes. Okay, no wait. Done. Okay, great. Zion. Okay. Cost in food record of keys. Print icons. Food. Yeah, I like this. I like Sunday's method as well. I like that method as well. Okay, so basic normal straightforward method. Let's see. Then we can try different methods. Really, the idea is using all the knowledge that you have learned to just try to solve, the problem. And like I mentioned, I'll show like I'll do like maybe they use the items. Do you remember the items method we discussed last class? That when you say list of tuples makes it super simple. Okay, so for food, any food stuff in food underscore record. I want you maybe try to use the way we did before. We say food underscore record, maybe dot keys now. And even if we do it the exact same way we did it before, right? Dot keys. So okay now. Okay, so first off, print. I want to show something food stuff. Oh. Record. Oh, I didn't actually run this kind of. Now, food stuff is printing the cost, not the food stuff for me. So of course, if I can see the food stuff, but actually the cost. Remember, the cost is now the key. The cost is the key. Yes, print cost. Yeah, it's the same thing, but I just want it to be intuitive, right? So print cost. So we know that the cost is the key. So that means where is it? Food. Can I say food? Food cost is cost. And where's that example? Food is food underscore record index, right? And what's the key? From what I've done now, what is the key? Huh? What's the key? Cost is the key, but now we put in a variable food cost. Yes. So on and print, whatever we want to print is really. So I bought food for cost. So I bought food. So I just like for cost. Now you can actually use cost. I just think just to clarify for food costs. So if you use cost, it's totally fine. You still get the same thing. So I bought cake for 50 naira, I bought yam for 40 naira, I bought this for 100 naira. But I really like this method that it does cost food, food dot items. Now items will return a list of tuples where each tuple is, let's take a look at it, where each tuple is, check it out. We call that, what's the food record, right? So food record dot items we return key value pairs as tuples. So you see, it has already joined it together for me as an iterable. So I can iterate through this directly, and I'll be iterating through the key and value pairs together. So I can just say for food, in food record of item, that is for each of this. This is one item in this. Is that clear? This is another item in food. This is another one. Here's another one, and here's the last one. So for food, for cost, food, right? Because there are two items in tuple in food record of items, we can just say again that print, and that's like the beautiful part for this one. We can say print. I bought food for cost naira. 2 lines. People, 2 lines. And you can use your print format method and other methods. So really it's about what all the things, little things we've learned, and being able to combine them to just solve some. So how many of us were able to, we didn't get the first one, but we got this one? Wonderful, one person. Anybody else? How many of us got the first one, we got this one? I know people that got it, people using their hands. People don't even want to. Okay, I'm still raising their hands in the chat. Okay. All right, so whether you got it, you didn't get it, please do go over the video and over the concepts to be sure that you really grasp them, so that before next class you can review again. And you see, I'm taking my time to really go over these items so that by the time we enter machine learning, we can move smooth. We can move smooth. Okay. All right. So I think we are good. All right. So we'll continue from here next class. We'll go to break and continue how you can interrupt. Okay. How you can interrupt an ongoing loop, right? You can interrupt the loop, say stop the loop, let the loop jump to somewhere. Maybe you want to stop the loop somewhere, or you are doing for when the loop gets to a point, you want it to stop and do something, all those kind of things. So we talk about break, continue, break, and continue, break or continue. That's just an interview way to think about it. But we'll talk about that next class. So thank you all for joining today, people on YouTube and Zoom. Really appreciate you. Thank you all so much. So we'll continue next week, Tuesday. All right. Thank you, Okoro. Thank you, Zion. Thank you, boss. Thank you, boss, too. All right. So enjoy the rest of your day.